Okay, so for 10b, the issue is that the student has tried to use 1/2 as a substitution to end up getting root 5 here. Now, the problem with that is the expansion is not valid for 1/2. It's only valid for when x is less than 1/3 and 1/2 is outside of that range. So the expansion isn't valid for 1/2. That's the error in the student's working. Substituting 1/2 into this will be completely meaningless because the numerator expansion is not valid for that. So that's the error. Now, part C is a bit trickier for me to explain. Because basically it's saying we can't do what the student wants to do. So how do we overcome that? Now, the overall aim is still the same thing. We want a value of x to substitute in here that will get us a root 5 at the end of this. Now, the student's working was to say substitute a 1/2 in and we'll end up getting 5. So then when we square root it, we'll get root 5. We can't do a 1/2. Now, the key thing here is we don't have to just have a 5 here because we can manipulate it at the very end. So if instead I was, for example, to rearrange this to get 5/4, and the reason I picked 4 here is because I know that will square root easily in a minute. So you could easily do 9 if you prefer, or you could do 16 or 25, any other square number. It doesn't have to be a square number. It could be any other number. You'll just end up with a third. Anyway, the point is, if I make that equal to 5/4 and then rearrange this, so I'll get 4 times 1 plus 3x equals 5 times 1 minus x. So 4 plus 12x equals 5 minus 5x. So 17x equals 1. So x equals 1/17. Now this is clearly inside the validity. My expansion is certainly valid if I use this. So the point is then, if I substitute 1/17 in instead of x, that will make the inside of my expansion 5/4. So let me just... So where we have our original question where we show that this is approximately 1 plus 2x plus 2x cubed. If I substitute 1/17 in here, I know that will get me root 5/4. And I'm allowed to substitute 1/17 in here and here because it is valid. On the left-hand side here, the root 5, I can simplify all of this to be root 5/2. And this is why I picked a 4, because it gives a nice 2 there. I can work out all this easily. And then whatever answer I get, times both sides by 2, and I've got an approximation for root 5. So that's how you should have done part C.